Okay, so here we have an 8-digit countdown clock for the first robotics build season. So it's just displaying the weeks, days, hours, minutes, and seconds until the end of the build. So the whole display is about 4 feet across by 1 foot tall, and it's using 8 of these 7-segment displays. And each one's maybe 8 inches tall, 4 inches across. And each one of the segments is individual from the digit itself. There's 2 pegs holding it in place into the board, and then there's also this one decimal point which has been relocated just for the colons. Yeah, it's all on one sheet of plywood. It has a couple coats of stain on it just to give it a nicer look, and then each one of these labels is just wood burned in. So yeah, I'll give you just a quick look at the back side so you can get a look at the circuit. So you can see on the back there's the wiring for each of the individual segments, and then over on the left side here is the power input. So there's a 20 volt DC power adapter being plugged in, and this is just an off-the-shelf buck converter, and it steps down the 20 volts to a more reasonable 12 volts for the LEDs. And then going in here is the driver board for the LEDs, and there's 4 of these, so the signal lines are just all in parallel, and then the power and ground are also going across over to the main board. So here's the main board over here, and I'll just take that out and get a better look. So here we have the ATmega 328 microcontroller, which is of course running the code and then all the inputs and the outputs. And there's the DS1307 real-time clock along with the crystal and the backup battery. Down here is just a breakout because there were some extra digital pins that weren't being used on the microcontroller, so those are just there as an expansion. And this is the programming header, so you can do some in-system programming. And over here on the right side is just the connector that goes over to the driver board. And on the back side you can see there's not much going on. There's an extra component here which is the 12 volt 5 volt linear regulator, and then this is an E2 prom which just stores the date and time that it's counting down to. So pretty much what it's doing is it has the time that it's counting down to stored in memory, and then it has the time the current time. So it takes the difference between the two, and then it just puts it into a format that's displayable in terms of weeks, days, hours, minutes, and seconds. Okay, so I'll just put that back in, and that'll start it back up. This connector is just connecting to the first driver board, which is running all the LEDs, and each one of them has a TLC 5940, which is a 16-channel constant current LED driver. So each one of these chips can control 2 separate digits. So the first 8 channels are being used for 1 digit and the colon, and then the second set of 8 channels is going to the next digit and the next colon. And then there's 4 of these across the entire board, which gives a total of 64 channels for all the 64 segments. Each one of the LEDs is rated for around 25 milliamps, but this is just set at a maximum of 20 milliamps just to keep it a little bit safer. They're configurable, so there's actually a resistor you can set to one of the pins to control the maximum amount of current, and then in software you can change, you can give it a value of what you want the brightness to be. It just changes the amount of current going to each channel. And then altogether with all 64 LEDs, on average, of course it depends on how many segments are lit up for what display, but on average it's running at about 1 amp, so 12 volts at 1 amp is about 12 watts. So it's not all that much power, but it definitely gets the job done. So yep, that's the entire project. Hope you enjoyed that.